Hello students, welcome to Software's classes. Today we'll be solving the CSIR UGC NET questions from the June 2018 paper. We'll be solving the set C of the Mathematical Sciences paper. Let's start off with question number 83. In question number 83 it has been said that let D be the open unit disk which is centered at 0 in C and F which goes from D to C be an analytic function. Now it has been said that if f is equal to u plus iv, where u and v are the real and the imaginary parts of f, and if f of z is equal to summation an into z to the power n, which is the power series of f, then f is constant if option 1 f bar is analytic, option 2 u of 1 by 2 is greater than equal to u of z for all z which belongs to D, option 3 the set an is equal to 0 for all n which belongs to the set of natural numbers is infinite, and option 4 for any closed curve gamma in D, integration over gamma fz dz by z minus a whole square is equal to 0 for all a which belongs to D with mod of a is greater than equal to 1 by 2. So these are the options that we have been given. So we have been given that D is an open unit disk which is centered at 0 in the complex plane, and f which goes from D to C is an analytic function, and also f is equal to u plus iv. Now if fz is equal to summation an into z to the power n, then f is constant, and we need to find out the conditions at which f is constant. So this is what we are concerned over here. So now in the first option we have been given that f bar is analytic. So now let us first we have been first told that f is an analytic function. Now let us start off with option 1. Now we have been given that f is an analytic function. Now if f is an analytic function, that implies that fz is free from z bar. This is one condition. Also in option 1 we have been told that f bar is analytic. Now if f bar is analytic, or this implies that fz bar is analytic, so this means that f is also free from z. So as you can see, f of z is free from z bar and also from z, so that implies that f is constant. So that implies that option 1 is correct. Now let us shift our focus to option 2. Now in option 2 we have been said that u of 1 by 2, that if u of 1 by 2 is greater than u of z, then f is constant. Now in option 2 it has been said that u of 1 by 2 is greater than equal to u of z for all z which belongs to D. Now we know that if f of z is analytic, we already know that f of z is analytic. It is not if, we already know that f of z is analytic on D. So that implies that which f is equal to now u plus iv. So this implies that u of z is also analytic on D. Now if u of z is analytic on D, then that implies that maximum of mod of uz is never attained inside D unless u is constant. But as you can already see that we know that D is a unit, D is basically unit radius disk which is centered at the origin. So therefore it lies between -1 2 1. Okay, it is a centered dish lies between -1 and 1, and half is somewhere between 0 and 1. So as you can see, in between within this d we are getting a maximum value of u. So that implies that, but we already know, but here we have been given that u of 1 by 2 is greater than equal to u of z. So that implies that u is constant. Now if u is constant, that implies that f, which is equal to u plus iv, that is also constant. So therefore option 2 is also correct. Now let's shift our focus to option 3. Now in option 3 it has been given that the set where n belongs to a set of natural numbers and n is equal to 0 is infinite, and in that case the function f is constant. So for this, let me insert a page over here. Let me insert a new page over here. So now it has been said that the set n which belongs to n in the set of natural numbers such that an is equal to 0, that will imply that f is constant. We need to check whether this statement is correct or wrong. Okay, so now we can think of a function fz if f of z is equal to sine of z. Now what is the expansion of sine of z? Now sine of z is equal to z minus z cube by 3 factorial by z to the power 5 by 5 factorial and so on. So this is of the format summation an into z to the power n. This is of this formula. So we already know that fz can be of this power series format. It has been already mentioned in the question. But now you can see over here that for n equal to even, when n is even, that implies that an is equal to 0. The coefficient of z square is 0, coefficient of z to the power 4 is 0. So therefore the condition that when n belongs to the set of natural numbers an is equal to 0, okay, that condition is satisfied. By f of z is equal to sine of z. But we know, f which is equal to sine of z is not constant. So that implies that even if this condition is satisfied, f of z is not constant. So therefore option 3 is false. Okay, so now let us move on to the fourth point. Now the fourth point is that let's go for option 4. Now in option 4 it has been said that integration f of z dz by z minus a whole square upon the closed curve gamma which belongs to d such that it is equal to 0 for all a which belongs to d and mod of a is greater than equal to half. So this is what we know. So therefore if such a condition exists, then we can find out f dash of a is equal to 1 by twice pi I integration over the area gamma f of z dz by z minus a whole square, and we know that this is equal to 0 when mod of a is greater than equal to half. We can extrapolate it further and we can write that, so that implies that f dash a is equal to 0 when mod of a is greater than equal to 1 by 2. And also the another condition is that for all a which belongs to d. And therefore we can also write that f dash of z is equal to 0 for all z which belongs to d when mod of z is greater than equal to half. Now by the identity theorem we know that by identity theorem, we know that f dash of z is equal to 0 for all z such that mod of z is less than 1. This is what we know. So that implies that f of z is constant. So therefore option 4 is also correct. So the correct options that we have got in this question are, the correct options are option 1, option 2 and option 4. So these are the correct options. So today we have solved a question. We solved question number 83 from the CSIR UGC NET question paper of June 2018. We'll be solving the next questions in the subsequent videos. Till then, keep watching Software's classes videos for more solutions and content. Thank you very much.